Welcome, postgraduate students. This is your comprehensive explainer for ZEIT8011 Space Systems Technology for Semester 2, 2026. If you're looking to understand exactly what this semester is going to throw at you, well, you're in the right place. Okay, let's dive right into this. For the next few minutes, I want you to think of me as your mission control. You're the engineers heading out on a critical mission, and consider this your pre-flight briefing. Over the semester, we're not just, gazing at the stars. We are getting into the absolute nuts and bolts of how we actually operate up there. Mastering these precise, highly technical details, that is exactly what separates theoretical ideas from billion-dollar operational satellites. We're talking about the high-stakes, real-world realities of space systems. Everything from satellite propulsion and remote sensing, all the way to attitude determination and aerospace structures. It's a massive field for sure, but we're going to break it down perfectly for you. Here's our flight plan for today. We've got 1. The launch pad. 2. Mission parameters. 3. Mission rules. 4. Flight trajectory. And 5. Mission control. Starting off with Section 1, the launch pad. This is our course overview. Just to set the academic stage here, this is a 6-unit of credit course, and it is delivered entirely online via UNSW Canberra at ADFA. Now remember, this is a postgraduate level journey. What that means is we're expecting a really high level of critical thinking and engagement from you as we explore both the ground and the space segments of these incredible systems. By the time you successfully wrap up this mission, you'll have nailed 4 primary objectives. First, you're going to critically evaluate past and future space technologies. That is an absolutely crucial skill when you're out there arguing for multi-million-dollar development budgets. You'll also learn how to apply expert judgment to construct solid arguments about where space tech is heading. You'll be appraising and critiquing industry trends, and crucially, you'll be able to research different spacecraft subsystems and explain exactly how they help pull off specific mission goals. Basically, you'll be selecting subsystems and analyzing mission tasks like a seasoned systems engineer. Moving on to Section 2, Mission Parameters. Let's talk assessments. Take a look at how your mission-critical milestones are weighted this semester. So, you've got 3 online tests. Test 1 is worth 10%, while tests 2 and 3 are 15% each. These are 1-hour timed, relatively low-stakes formative tests. They're really just designed to consolidate your learning progressively as the course content builds up. Keep in mind you only get 1 attempt at each. Then, taking up that massive 60% remaining chunk is your final assignment. This one's a 6,000-word deep dive, and it requires some serious, independent thinking that goes way beyond just memorizing textbook facts. All right, Section 3, Mission Rules. Time to pivot to these strict AI policies and penalties. We need to draw a very strict line right here regarding generative AI. For all 3 of your online tests, AI tools are strictly banned. Period. No assistance whatsoever. But for that huge 6,000-word assignment, you are allowed to use AI for planning assistance. That means you can use it to brainstorm ideas, structure things, or create outlines. But, and listen to this clearly, you have to develop those ideas yourself. Absolutely no AI-generated text or media should make it into your final PDF submission. If your convener spots unmodified AI text, you're going to be looking at a formal academic misconduct investigation. And nobody wants that. Let's talk deadlines. There is a strict 5% late penalty applied per day for any late submissions, and that's capped at exactly 5 days, or 120 hours. Once you hit that 120-hour mark, you literally cannot submit the assessment, and a grade of absolute 0 is applied. The only exception to this rule is if you've been granted formal special consideration because of unexpected, unavoidable circumstances. So make sure you manage your time like a real launch countdown. So the crucial point here is you really don't need to panic if you stumble on a single test. The overall pass mark for the whole course is just 50%. You simply need to accumulate 50 out of 100 total marks across all your assessments to pass. There's no minimum mark required for any one specific assessment item. Next up, Section 4, Flight Trajectory. Let's map out your 11-week schedule. This timeline maps out the major milestones you'll hit across our 11-week journey. Test 1 lands right on the census date, which is Thursday of week 4. Then, just 2 weeks later, Test 2 is due on the Sunday of week 6. Test 3 comes up on the Sunday of week 9. And finally, that big 60% assignment is due on the Sunday of week 11. Just a heads up, the tests are open for a full week, but they absolutely must be completed by these exact close dates. Now, what's really interesting here is that week 4 introduces absolutely 0 new teaching material. We built this in as a breather. It gives you dedicated time to catch up, review the first 3 weeks of content, and properly prep for Test 1 before that census date hits. Similarly, weeks 10 and 11 are totally reserved for you to focus purely on executing that final assignment, though we'll still be running weekly support sessions if you need them. Finally, Section 5, Mission Control. Let's look at your support and resources. Remember, even in space, you're never totally alone. Your course convener and primary point of contact is Lily Kiao. She's based over in Building 16, Room 204. If you need to arrange a meeting to hash out some of the course material, just make sure you email her in advance. And please always include the course code ZEIT8011 right in the subject line of your email so she knows exactly who you are and what you need immediately. You've also got a ton of resources at your disposal. Moodle is going to be your main learning management hub, and you'll have weekly 1-hour live sessions happening via Microsoft Teams. Oh, and here's some fantastic news. You don't need to buy any textbooks. Digital chapters from your prescribed texts by Warts and Fortescue are going to be provided to you week by week. Also, I highly recommend attending the optional space education seminars. They feature actual industry professionals working on real space projects right now. It's the perfect way to bridge the gap between your textbook theory and actual real-world engineering application. We also want to shine a quick spotlight on Equitable Learning Services, or ELS. If you're a student living with neurodivergent, physical, or mental health conditions, or, hey, if you're caring for someone who is, ELS provides free, totally confidential support to make sure those conditions don't get in the way of your studies. Please don't hesitate to reach out to them if you need practical support to make your education more equitable. They're there to help.
And just like that, we're at the end of our briefing. The technology behind space systems is quite literally one of the most exciting, fast-paced fields in engineering today, and you're about to be right in the thick of it. Your very first administrative step is to log into Moodle and get familiar with the site. But as you do that, I want you to ask yourself this. With space technology advancing faster today than it did during the entire Apollo era, what kind of new system will you be designing by the end of this semester? Good luck out there, engineers. Prepare for liftoff.